This example puts some key ideas together. The first is a JMSL instrument. An instrument is responsible for actually interpreting numerical data. That interpretation takes place in this method, the public double play method, which receives an incoming timestamp, a time stretch scalar value, and the actual numerical data, which is stored in an array of double. The responsibility of the play method is to actually do something with the data and to return the updated playtime based on the data. The data usually has the duration stored in the 0th position of the array. So here is where we pull that out, duration equals data sub 0. Then it does something. It could play a MIDI note or a JSON sound or draw something, or in this case, print some information out about what it's doing. Here, though, is an important point. You return the incoming playtime plus how long this thing took. And it takes the duration times the time stretch. Time stretch is typically 1, but it could be 0.5 or 2 or 3.6 or whatever to slow down or speed up the interpretation of that duration. So you might implement tempo that way, for example. Okay, so what this does is actually just prints out the playtime. It identifies itself as being an instrument that is playing, and then it iterates across the array and prints out the value in each array position. Okay, so that's an instrument. An instrument actually has a lot of methods, so the easiest way to create a custom instrument is to extend instrument adapter and override the play method, as we've done here. An instrument is also included in a MusicJob by default. So you can set an instrument in your MusicJob to anything you want. In our example, here in the constructor of the instrument playing MusicJob that we are subclassing, we set the instrument to a new custom printing instrument, in other words, one of these. Then in the MusicJob's repeat method, which happens some number of times, as you've already seen, the repeat method receives the mathematically accurate timestamp, and it's tasked with doing something with it. In our example, we are going to just print out the playtime and the repeat count, and we're going to create an array of data with 3 elements in it. The 0th position is going to be set to 2, so that's 2 seconds. The next one is going to be set to a random number between 0 and 1. And the next one is going to be the result of making a call to a Gaussian distribution. All right, we're not actually doing any sound with this. We're just generating data algorithmically and printing it out. Here's an important notion now. The instrument's playtime, recall that it is responsible for interpreting the data as duration. So it returns the updated playtime. That means the repeat method, if it calls its instrument and asks it to play this data with this incoming playtime, it will receive the updated timestamp from instrument.play, and that's what it returns. So if it's noon and get instrument.play interprets this data to last 2 seconds, then it'll return noon plus 2 seconds here, and that means repeat will return noon plus 2 seconds here, and that's what will cause the repeat method to pause for those 2 seconds. All right, let's watch it in action. There we have the MusicJob's repeat is announcing itself. It's showing you what the playtime is and that the repeat count is going up from 4 to 5 to 6. And every time it's calling instrument.play, which is what is causing this printout. Custom instrument.play is showing you the playtime, which is exactly the same playtime as was passed into repeat. So there is absolutely no loss of precision. That's exactly the same timestamp. And the data is being printed out by the instruments.play method. So here we see that it's always 2 seconds. That's the duration. And then we see the random number between 0 and 1. And then we see the output of the Gaussian distribution function. Sometimes you get a -1, sometimes you get a 5.6, whatever. Okay, so the big point here is that the instrument can operate arbitrarily on data and do something with it, whether it's make sound or print data out. Its play method is responsible for interpreting the data and returning an updated duration. And if you use instrument.play in a MusicJob's repeat method, you can make use of that, the semantics of play, by returning the updated playtime that the instrument's play method returns, so that you can generate data, ask the instrument to play it, then generate some more data, ask the instrument to play it, generate some more data, ask the instrument to play that in a loop, in a repeating scheduled loop.